yesterday we wrote our equations. We defined our variables and we wrote the equations, and now we need to come back and take these two equations and solve them. So we've learned 3 ways to solve equations: graphing, substitution, elimination. You can solve these with any of the 3 methods, but graphing's usually not your number 1 go-to option, and so we can solve these either by substitution or elimination. Anybody have a preference here on this one? Since this is already solved for W, the way we set up this equation, this particular one, because it's already solved for W, it would be easier to solve this by substitution. This would, like when we did substitution, we had our 3 columns. This would be our first column. And this is going to be our second column. 24 equals 2L plus 2W. And in place of this W, I'm going to put this part right here, because this part right here is equal to W. So I'm going to have the 24 equals 2L plus 2 times 5L minus 30, because this part in parentheses is equal to the W. What do I need to do to solve it? What do I need to do with this 2 out in front here? I don't hear everybody telling me to distribute. That's what you're thinking in your mind. 2 times 5 is 10, and 2 times 30 is negative 60. Combine like terms, and that's 12L minus 60. What am I going to do with the 60? Add it. 84 equals 12L. I'm running out of room. I will divide both sides by 12. So, how many times does 12 go into 84? Yes, 7. And so this is a length of 7. 7 what? Meters, because the original problem right here was in meters. Have we answered the question? Find the width. Have we found the width yet? So we are going to go back to our width equation. In place of the length, what are we going to do? How much is the length? What's that going to be equal to? That would be 35 minus 30, so the width is 5. Are we done? Up at the top of your page, what does it say that part 4 is? What does it say we are supposed to do? So, the solution is not 5. The solution is not 5W. The solution is the width of the rectangle is 5 meters. Is that a complete sentence? I may not be an English teacher, but I am a college-educated person. I can recognize a complete sentence. So please put your answers in terms of a complete sentence. For the next problem, just for variety's sake, this one also could probably be done pretty easy by substitution, but just to show you that it doesn't matter, I'm going to solve this one by elimination. So here is my first equation. To solve by elimination, I need the columns to be lined up. What comes first over here? See, not 4L. What variable comes first? What variable comes first over here? And so in order to get the columns lined up, I'm going to subtract 2L from both sides. And so this equation would be minus 2L plus 1J equals 1. And I just did that so that my columns would be lined up. Because if I'm solving by elimination, I need the columns lined up. Now, if I'm solving by elimination, which one do you think it's going to be easier to eliminate? The L or the J? So if I'm going to eliminate the L, I'm going to need to multiply both sides of this equation by 2. So the first equation is going to be 4L plus 7J equals 169. And if I multiply that plus 2J equals 2. Add up the columns, what happens to the L's? So this is going to be 9J equals 171. So 9 will go into 171 how many times? Double checking my math. It will go, so J is equal to 19 when you divide that. Did somebody check my division? What was the original question? Do we have to find Lisa's age? We could by plugging this 19 back into the original equation, but do we have to in order to answer the question? No. So can we answer the question? Jane is 19 years old. We could find both of them, but we don't have to. Since this is already solved for G, substitution is probably easier than elimination, especially since we'd have to distribute and get all of our columns in a row. So it's probably easier to use substitution. Do you understand why I'm saying that? Okay. We already know what G is. This is already the first column when we were doing it on our paper with the columns. So this would be like my second column. And what is G equal to? in place of G, I'm going to substitute 3D minus 1. And then I have the plus 7, and I'm going to go ahead and distribute here. And then I'm going to combine like terms. These two terms combine. 4 and 14. Subtract 2D from both sides to get my variable together. Subtract 6 from both sides. This particular question said find both of their ages. So are we finished? So we have to go back to our first equation. So this is 3 times 12 minus 1. 3 times 12 would be 36. 36 minus 1 would be 35. So who's 35? So what would our solution look like? Mrs. Garcia is 35 years old, and her daughter is 12 years old. Does that answer in a complete sentence? Okay. When we get to the quarter and nickel problem, you have a choice. You can use dollars or cents. You can use decimals or not. Which one? Anybody have a preference? So, since this is already solved for quarters, we'll go ahead and use substitution. So, we'll just go ahead and use the first equation with the decimals. So in place of the quarters, I'm going to substitute this in place of the quarters. And so 0.25 plus 0.05 equals 8.40. And then what's 4 times 0.25? And so combine like terms. Divide both sides. One will go into 8 times. 5 will go into 48 times. So the number of nickels is 8. So the number of quarters is 32. So 1 has 8 nickels and 32 quarters. You could put for a total of $8.40 if you wanted to add a little more to your sentence. This one is also probably best solved by substitution, because I wouldn't want to try to multiply by those decimals to make all the decimals work out. So if I'm solving for by substitution, this is going to be my first equation, and it is not solved for one of the variables. So do you want to solve it for x or y? It doesn't matter. The choice is yours. So somebody chose an x, so that x would be equal to 30 subtract y. Then this is your second equation, and I'm going to go ahead and multiply 1.17 times 30, and so when you multiply 1 times 17 times 30, that is $35.10. I got that number by multiplying these two together. Okay, and in place of the x, I'm going to put 30 minus y. 1.05x plus 1.35y equals 35.10. Double checking my multiplication. This is going to be 3150 minus 1.05 y when you distribute, plus 1.35 y equals $35.10. When you combine like terms, that's negative and that's positive, so you would subtract, and so that's going to be I hit something wrong on that. And so then I need to combine like terms again. I need to subtract this from both sides. And so this is going to be 3.60. Last step. Y is equal to 12. That's what you get when you divide that. 3 will go into 36 12 times. And then x plus y equals 30. Did it say find both? How many pounds of each kind? Yes, we have to find both kinds. Read the original question to make sure we're finding out what we were supposed to be finding out. What did x represent in this problem? So, doesn't give a person's name. So, we would need to mix 18 pounds of $1.05 candy with 12 pounds of $1.35 candy to get 30 pounds of $1.17 candy. Here is the last problem, the last two equations. See if you can solve it. As I said just a minute ago, I wrote this equation kind of sloppy. That should have been x equals 7 plus 2y. And so then when you substitute in this equation, you should have gotten y equals -4. Boy, I'm being all kinds of messy on this problem. And then when you substitute the -4 into this equation, you should have gotten a -1. The larger number is -1, the smaller number is -4. How did you do on that?